So I really appreciate that systems architecture or solution architecture approach that you guys have.
Uh, This is basically as a result. This is not a conscious decision, by the way. It's a
Oh,
result.
great.
No, absolutely not, because it's a result of consulting experience,
Okay.
working with various companies.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On today's episode, The Lost Art of System Architecture, with special guest George Dalleman, co-founder and CTO of Vixtera. George, welcome to the show.
Thank you.
Hey, George, we've known each other for like 5 or 6 years. Has
Yeah,
it been
it's
that
been a
long?
while. Yeah, it's
Yeah,
been a
and
while.
you're founder of Vixtera. We're going to talk a little bit about Vixtera, but before we get into what you guys do and this whole IoT space and managing it, everyone wants to know your background. I want to know. I know your background, but it's a fascinating background. So let's hear your backstory, George. Tell us a little bit about yourself.
um, Everything is fairly simple. I was born in last century in a country that doesn't exist anymore. Uh, the young generation maybe not even remember that Soviet Union was a country, one of the world forces. But anyway, so that was the country. In a middle class family, maybe a little bit above average. My dad was a vice president of a company, obviously state owned. My mother was a teacher. Um, School, math, technical university, they call themselves now, used to be Kishinev Polytechnical Institute, systems and networks. Graduated from there, um, worked for a company that was making water pumps, but Soviet Union was a very militarized country and very secretive. So what they did in order to hide the military production, they had units in regular civil enterprises that were manufacturing some kind of military equipment. So these water pumps, they were water pumps, but they were for cooling nuclear reactors in nuclear submarines.
Oh, there you go.
Yeah. What I was doing is I was building a system that was gathering the information from vibration sensors and analyzing noise. The whole idea was to reduce the noise so that the submarines would not be detectable. Uh, Unfortunately, we were successful enough. uh, and after that, I moved to Moscow, worked for the Academy of Science, postgraduate, and in the late 80s, early 90s, the doors of the Soviet Union, which was a very closed country behind the Iron Curtain, opened a little bit. I was first in the row, and I've got into the United States, and that was in 1991.
Wow.
Yep. Since then, I was working as a consultant. I was living, and I still live in Michigan. So automotive industry. I was working for Ford, and then I was working as a consultant for quite a while as a full stack developer. At some point, I developed a UI framework to make my life easier, and it was noticed by EMC Documentum. So they invited me, made me an offer that I wasn't able to refuse, and I moved to California as a client architect for Documentum. I was responsible for the laptop, the old version, the new version, and stuff. Um, After that, I moved. Well, because of family circumstances, I had to move back to Michigan, and I've got a call from my friends from Documentum. Can you do something for us? And I said, of course I can. And I did that. And then there was another contract, and then there was another one. And so Vixtera started as a consulting company. Um, it wasn't kind of an intention. It wasn't an intention to grow it to Intel. It was just like make a decent living and have fun along the way. So it has been 15 years since then, and we're actually kind of moving in that direction. Um, uh, Eventually, we decided that we want to, I wouldn't say completely move away from consulting, but move into more like into a product space. And because some of what we were doing was DCIM, we got a lot of expertise in that. And we saw the mishaps of the system. We saw the places where we can improve. So we actually built a data acquisition system, which can be used as a DCIM or basically IoT, industrial IoT platform. We call it vEdge.
What I've been impressed about, George, working with you guys, is that you look at full architectures. You really do a holistic view, which I find really important, especially in the world that we have today. And you can argue with me on this one, but I think software industry as a whole, we've kind of abandoned really good systems architecture and in its place we said everything's just going to be a microservice and we don't have to worry about the fundamentals of cohesion and coupling and modularity and simplicity and well-defined APIs. I've seen this over and over again, and when I look at your guys' architecture, I'm like going, whoa, you guys have a real architecture, which I haven't seen. I used to see a lot more in the late 90s and early 2000s, but we kind of abandoned it. So I really appreciate that systems architecture or solution architecture approach that you guys have.
This is basically as a result. This is not a conscious decision, by the way. It's a
Oh,
result.
great.
No, absolutely not, because it's a result of consulting experience.
Okay.
Working with various companies and seeing that what they do, starting with small ones and ending up with like something like VMware that built VMC 2.0. You start realizing that many things are repeatable. B, they are all layered. Small ones, large ones, doesn't matter. And the layers are pretty much the same. It's basically, when you start thinking about it, the difference would be more or less implementation and picking up the layers that are applicable to that specific application.
So would you say, so would you say you have kind of this general repeatable architecture that you can use for almost any project, that you've kind of established this as Vixtera, as your company, that you can reuse over and over again, and you just activate different layers depending on the project? Is that how you see it?
Pretty much. I would even say not activate the layers, but more or less activate the functional blocks within the layers.
Oh, wow.
The layers is pretty much always the same. Look at it. You have the API surface, the public API. Then you have a set of functional blocks, because you don't start the architecture with services. You started with functional diagram.
Right.
So you have the functional blocks that are responsible for operating with the API surface. And then you have something that supports that these, let's say, domain services. And this would be the platform layer. And the platform layer would be doing basic things. It will be doing data access. It will be doing messaging. It will be doing workflows and so on. And so the functional blocks, you just turn them on and off, but the basic architecture is the same. And the one that you showed me, it's basically pretty much
It's basically the
thing.
same. Yeah. Yeah. Because I've got my enterprise architecture that I use for all my stuff, and your stuff, and independently, great minds think alike, George.
Yeah, they usually do.
So have you? What made you guys move into? Because when we first talked, you guys were squarely in the multi-hybrid cloud space. What made you move into more of the edge device management space, and what challenges did you find in that space?
As a consulting company, we were basically doing two things. Three, but one is small projects, which is not that interesting. Two things. We were doing cloud, complex things in the cloud, architecture, services, distributed systems, stuff like that. And the second, historically, we were working with data collection systems like DCIM for data centers. We used to have a project that was collecting data from sensors through SIM cards, and so on and so on. And we were doing it for ages. And because we were in that space and we had that expertise in building systems like that, and we saw over the years that capabilities in there, that the systems that are around there are not flexible enough. They are not interacting with each other in the right way. They are not scalable to the necessary extent.
And
So
what
we
would
decided,
you attribute
yep,
that to, George? I mean, you would think that those systems would be the most scalable, the most flexible. Why weren't they?
historically, that the way they were built. Let me give you an example. You have a sensors or a device as a group of sensors, and you want to buy a new one and include it into your existing system. So what
Right.
would you do? Today's approach, you will write the code. You call it the driver, and every time you add a new device type, you would need to write code. And writing code, you can imagine it's a standard procedure. You write code, you test it, you deploy it. So it's a whole process. So adding a simple device, which you have to do tomorrow, will take you several months to not just because writing a driver, because you have to
Oh,
go
right.
through a
Yeah. Yeah.
standard
That
process.
takes time and testing, and
Mhm.
yeah.
That would be one of the scenarios that where that needs great improvement. So what we ended up with is we developed a system with called logical protocols that allows us to declaratively define how to work with sensors and devices. We support standard physical protocols, SNMP, REST, Modbus, whatever we have, like 5 or 6 of them. But we are capable of declaratively defining how to communicate with the device logically. By the way, it's patented.
So you guys create an abstraction. So now I can focus on the platform layer, the functional blocks. I can write those functional blocks independent of the devices because of the abstraction layer there, right?
We abstracted, basically, we went through the same architecture. We have an API surface. We
Right.
have Yeah, we have functional blocks that are dealing with that API surface. That is the device polling, inventory, device type support, and stuff like that. And then we have another layer, which is the platform layer. And the platform layer, it is responsible for three things: saving data as time series mostly, uh, event bus, which is a messaging system. And the third layer is the actual work layer that contains agents that actually talk to the device. On each level, we have its own abstraction that allows us to easily replace every functional block, and all the layers are communicating on that abstraction level.
So this is what I really love teasing out with you on this, George, is we we kind of have forgotten some of these core foundations like abstraction, adapter patterns, and things like that, which you guys are taking advantage of, and you can move much faster than someone that's created a full stack that's tightly integrated because you can handle a lot more um, devices, a lot more use cases, and things like that. How do we teach the next generation these core concepts that you and I both understand, right? Because we've lived through it and we help create these things. How do we get the next generation to adopt it quicker so that they can go on and create new types of advances in software engineering?
That's a very good question. And I was making an attempt to answer that question many times because you need qualified people working for your company. We're not a big company. We're a small company. We have like around 100 people altogether. And the only way we can compete is to get a certain level of expertise of the people that are working on there. So training people that work for us is one of the most important parts of what I do. But the problem is that the personnel that I'm getting from the universities, or let's say from other companies when we are hiring contractors, um, they're smart, they're bright, they are willing to go, they don't know anything, just zip. Uh, they can code on Python and or the best case scenario on Java, and that's about it. Uh, Today's universities are not teaching any architecture. They're not explaining this the whole big picture of what architecture represents, because it's not just technical. You have to. It's an art of compromise. You I don't want to go there. It's a huge story that you have to explain. It probably will take a year or two of teaching people just to get the beginnings of that. Because when you build an architecture, think about everything. You think about interacting with the outside world. You think about distributing. You think about testing. You think about a whole bunch of things that lead to a reliable, scalable application. No,
So is
yeah.
it something we can't teach? Or we can teach these principles, but they're not doing it because it's tough, it's hard, and it's not really a computer science thing anymore. It's not just algorithms, right? This is more software architecture, software. It's a different skill set than just typing code, right? Or
Absolutely.
understanding an algorithm.
I would say uh, if there would be a course that would explain how to build complex distributed applications with examples, with labs, with everything, that probably will lead to. So you wouldn't get architects right away. You need experience, obviously,
Right,
but
right,
at
yeah.
least you will get people to understand what does it take to build the right architecture. because there are many kinds. It's not necessarily software architecture. It's also have to think about monitoring, which is a completely different architecture, but they work together. There are so many aspects, and you at least have to tell people what these aspects are and how they communicate to each other, and what do they have to do in order to make that work together. And nobody teaches that anymore. And then so today people are getting it through experience, and you would not be able to build or understand how a complex distributed application works unless you are in a company that does build that application.
That does build those, but most companies aren't willing to spend the time, right? To do it right the first time. They're in such, I gotta hit the ground running. I've got to deliver product before my competition does. So
yep,
they sacrifice short-term gains for long-term, stability and things like that.
Not that many companies do that. Some do. I've seen that. I've done that with VMware would be a good example. I know Intel is doing that too. I haven't seen that many. And yes, to get that experience, I have to do it, and not that many companies doing that. That's true. There are so many aspects. One of the aspects, obviously, is a financial aspect. So the thinking is, let's get 200,000 people, write everything in a month, and spend $1 million, and we're done.
That's the monkey typing keyboard problem, right? I mean,
yep.
that's a, hey, just throw enough people at it, it'll work. That doesn't work.
Yep. Besides the fact that it wouldn't be high quality, nobody thinks about long-term maintenance. When you're building an architecture, you're building actually a story of a life cycle of an application. That's what you do. And if you don't have it right, then you will spend gazillions maintaining it. And you see it all over the place.
Yeah, we see it all over the place, especially companies that acquire technology through acquisition.
Mm-hmm.
I've seen this time and time again. And then they throw a bunch of software guys at it and say, integrate those, and they just glom it all together, and no one's looking at the overall architecture. It's a huge problem.
Yep. Well, there's a bright side to that.
It keeps us employed. So, all right. So George, let's talk a little bit about new technologies that could be very disruptive in the space of software engineering. And the elephant in the room, of course, is generative AI. So with generative AI, because I've been using it, I'll admit, it takes care of some of the programming stuff for me. And I focus more on the systems architecture stuff, and the programming stuff, I let it do some of that for me. I have to double check it all. Do you think generative AI is going to benefit our industry, the software engineering and software architecture industry, or is it going to hamper us at first? What's your thoughts on that?
We used it in a few times, pretty much not to write code for us, but let's say we have Python code that we want to convert to Java.
Okay, yeah.
So you split it into small portions, you feed the portions to the AI, and it will basically give you more or less decent result. Of course, it has to be worked on. And so is there a huge benefit in that? I wouldn't say. Writing code is not art anymore. Yeah? Writing code is technology and methodology. So it moved from the art of coding to basically a conveyor job. Can AI help in that? Yes. Do we want it to? I would say no, because it's dangerous. AI is dangerous, not in a sense that it will kind of overtake humanity or kind of destroy us. It's dangerous in the sense that we moved things that make us think or should make us think to AI. Coding is a technological process. Yeah, it can be easily automated through AI,
Right.
but still, when you do that, it gives you a certain discipline of mind. It's pretty much like math. You have to understand how that works. Without actually doing coding, you wouldn't be able. If you didn't do coding before, you wouldn't be able to do any architecture.
So yeah, that's a fear I have as well, that we might be losing some skill that is vital for us to develop really good architectures later on. Because I know a lot of work that I do with my software development would take me hours and hours and hours to do. I can do in minutes now with Gen AI because I don't have to go researching for an API or a new technique. I can ask it; it can give me some samples, and because I've been around it for so long, I can interpret that very easily. But my children and these Gen Z and millennials that are programming now, if they're using it constantly, they're not learning. They're just relying on it. So it becomes a crutch. Is that
Uh,
what you're
but that,
seeing as well?
but that, yeah, absolutely. But that's a common problem. It's not just
Yeah. We've had
programming;
this
it's
problem for,
everything.
yeah.
No, it's not. It's just the direction we're moving. We're uh, offloading problems that we have to solve ourselves onto AI. Speech writing, I don't know, journalism,
Yeah. It's a problem all
whatever,
over the place, right?
everything. Writing a thesis today, you can use AI. I've read a couple of articles where people were getting their diplomas written by Chat GPT. So it's a common problem. The, I don't know. We wouldn't be able to fight it. It's done. It's a done deal.
So so yeah, it's already a done deal. So
Mhm.
how do we incorporate it? How do we? Because if we want the best software engineers, let's say in your company, you want the best software engineers in the world. The only way, because we talked about, you're going to have to groom these guys yourself. You're going to have to teach them how to be the best software architects in the world. What do you do? Do you leverage? Do you teach them how to use the tool to be more effective?
Oh no, absolutely not.
Oh,
No,
okay.
we're doing it. We're doing it the old-fashioned way. We're coding manually. Every lead that we have that runs a team must spend at least 20% on coding, besides everything else, even though they're doing the design and sometimes the architecture, they have to code. Everybody in the team codes. Sometimes we use, as an example that I gave you, we use the generative AI to do certain things that we don't want to spend time on. But other than that, we're actually writing the neural networks ourselves.
Wow. All right. So, well, because I understand your philosophy behind this, it's so they can learn, what's really going on underneath the covers, right?
Don't take me wrong. Everything that is AI, well, it's artificial, but it's not intelligence.
No, it's
Let's
not
put it that
intelligent.
way. Yeah.
It's just a math. It's just an
Uh,
algorithm, right? It's a big in by in matrix.
it's a brute force algorithm. It's also we have to
Eh,
understand that too. But it's a great tool, and it's there, and it's going to be there and it's going to be better and better and better, and the humanity will become more and more stupid as a result of that. So we have to live with that, and you can apply either that philosophy or this philosophy. It depends. It pretty much depends on the company and the individual.
Yeah.
I'm pretty sure that eventually AI would be able to do the architecture too.
I hope not completely, George. I like doing
Well,
it too much.
we still have some time.
Yeah,
Yeah.
exactly. Hey, George, if people want to find out more about Vixtera and your products, specifically your data collection systems, for edge devices, where do they find out more information?
Vixtera.com.
That's VIXTERA.
Yep.
Yeah, .com.
And also our CEO, Greg Ioffe, he's running a great blog on LinkedIn. So you can find a lot of information in there too. And basically that's the best way to connect to us, although you can obviously write an email or give us a call. But going to that blog will help a lot to understand what system is doing and how it works.
Perfect. We'll make sure that we put those links on the embracingdigital.org website with this podcast. George, it's been wonderful having you on the show today. Great conversation. I love talking to other solution architects like yourself because we could get down in the weeds on things. So thanks for your time today.
Thank you for having me, and thank you very much.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.